So actually, before I get to the nice graphical effects, let's do one more thing, and that's to update our shooter just a little bit. If we're to take a look at the real Peggle game, or at least my flash approximation of it, you can see that the area that the ball shoots from isn't actually a point that stays the same on screen the entire time. As I move, sorry, that's my cat. As I move, the point at which my ball gets shot from changes basically along this little arc. And so we can reproduce that pretty easily within our Puggle application. Let's find out how to do that right now. Now, once again, I'm probably going to have to subject you to my terrible art. I apologize for that. But, well, that's the way these things go. So I'm going to create a new symbol here in Flash, and I'm going to call it a shooter. And we can remember to export it. Its base class will be a sprite. And this is basically just going to be like a... Let's make this a big old cannon-like thing. So we'll make it, I don't know. How about this kind of lavender color with a dark blue outline? So we'll do something like this. You know, let's make a circle. Fantastic. I'm going to, let's make it 90 pixels by 90 pixels. We can set her at -45, -45. And then the place where we're actually going to shoot our ball out of will be this little rectangle that I'm going to place on the side here. Wow, it's amazing that no one has actually contracted me to do freelance artwork. They clearly don't know what they're missing. So the one thing I'm going to do here is I'm going to make a little note of where the end of this shooter is. Look over here, let's say. It looks like it is basically, the x position is 70. So we know that at point 70, 0, that's basically the end of the cannon. And this is probably where we want to shoot our ball out of. So we'll remember that. Now that we've created the shooter in our library, let's go and create the class in our code. So I'm going to create a new class, and we're going to call it shooter. As you remember, it extends sprite. And I'm going to create a constant here that we'll call, I don't know, ball offset. That will be a point at 70, 0, which corresponds to the end of our cannon. Now the shooter is going to be responsible for two things. The first thing it's going to do is follow my mouse movement on screen. You know, when I move my mouse around, we should have the shooter basically rotate to match where my cursor is. So I'm going to do that, at least for now, just by creating an event listener for enter frame, and we'll have it call a function like align to mouse. Boy, that's an awful lot of pop-up hints. All right, there we go. Now basically for this function, what I'm going to do is take a look at where the mouse cursor is in relation to the shooter and essentially rotate my shooter so that it points to the mouse. Now, there are lots of ways to do this, I imagine, and I'm guessing there's probably one that's less convoluted than this, but this just happens to work, and I remember just enough trigonometry from high school to be able to get this to work. If there is a better way, I would be glad to hear it. But this is what I do. I'm going to calculate basically the mouse angle, and this is going to be a number, and it's basically going to be the angle in radians that I need to rotate this object to align to where the mouse is. And I'm going to be calculating this using the arctangent2 function. You pass this function a y value and an x value, and it essentially gives you the angle. And so I'm going to calculate the angle by taking a look at the mouse y value on the stage and subtract from that the y coordinate of this sprite. Again, I have to be taking a look at the y coordinate of the mouse on stage rather than in relation to my shooter, because as I rotate my shooter, that angle is going to change, and I haven't figured out a way to compensate for that. Again, there's probably a very simple way of doing this using like polar coordinates that I just haven't figured out. This is just sort of a, I guess, an idiom I have used a few times, and I just happen to know it works, so I keep using it. So I'm going to take a look at the mouse X minus the X value of this shooter. And then because this is in radians, I'm just going to multiply all of this by 180 over pi. And that gives me the angle that I need to rotate to in degrees. And then all I have to do is set the rotation equal to that mouse angle. Okay, so that was probably more math than we've actually had to do so far in a game that involves physics, which is kind of surprising. But let's just make sure this works now. I'm going to go back to my Puggle application. I'm going to go all the way up to the top, and I'm going to create another member variable called, we'll call it the shooter. Now I can jump down here and say before I create my aiming line, I'm going to create my shooter. I will add the child. And I probably need to put these someplace. And actually, you know what? That launch point constant is probably a good place to start. All right, let's just give this a quick test run to make sure it all still seems to work. All right, so that's pretty good. Actually, our shooter is tracking our mouse. And, you know, it actually looks like our ball is getting shot out of the end of this shooter, even though you can tell that's not quite the case. By the time we get to these extremes, you can kind of see the path of the ball has dipped a bit so that it's just kind of hitting the lower end of our shooter. Really, our ball is getting launched from the center of this thing, which we don't want to do. So let's quickly fix that. I'm going to go back to my shooter. I'm going to add in one more function here that I will call, it's going to be a public function. I'm going to call it get launch position. This will be a point. And basically all we need to do here is take this ball offset that we have defined above and return the value of this after we have gone and rotated our sprite. And I don't even need to do any math for this. I can just call the local to global function, and I'm just going to pass in the ball offset, and that's it. Actually, that's all I need to do. So now we're going to go back to my Puggle application. I'm going to first do two things. I'm going to rename this launch point to something like shooter point, just so I remember what this is. Now I got to make sure I change it here. The other thing I now have to do is look at the places where I have called launch point. The first place is when showing our aim line. Now instead of using this constant of launch point, I am basically going to create a little local variable, and I'm basically going to ask our shooter to get our launch position. I can now drop this in these two places. And then the only other place where we need to do that is basically here in our launch ball function. So again, I'm going to create a little local variable called launch point. It's going to be our shooter's get launch position function. And I'm going to put it here and here. So maybe that went kind of fast. Let's review. Over in my shooter, I created a new public function called getLaunchPosition that said, hey, this is where the end of the cannon is now that this shooter has been rotated. And then over in my Puggle class, every place where I before had my launch position as a constant, I now created a little local variable and got my launch point from my shooter. And so now when I call this, I'm not going to get the same launch point all the time. I'm basically going to get where the edge of this cannon is in my global coordinate system. So I hope that all made sense. And so now when I run this, the difference is kind of subtle, but maybe you can see that my aim line is no longer dipping to the very bottom of my cannon when I move to the extreme left and right sides. And that indicates that my ball is getting shot out of the end of the cannon instead of the center of the cannon. And so that'll give us sort of a slightly different aiming mechanic. And so there you go. All right, so I think that's probably one of the last features I'm going to add. Now I can go back and look at what I was going to do in this lesson before I changed my mind and did things out of order, and that's to maybe put in a little tweening to make things look a little nicer. That'll be next.